Good morning. So I want to talk a little bit about what is an agent and where did this all come from. So when the modern AI era was kicked off with ChatGPT, largely a few years ago, we thought of these AI systems as things that a human would talk to a large language model. Maybe that large language model had access to some database. But fundamentally, this was about chat, people talking to AIs. But this has evolved considerably. Today, we really think of a complete autonomous system. This is made up of many models, some open weight models, some proprietary models, access to tools, infrastructure, memory systems, context management, ability to spawn sub-agents, security infrastructure. And there might be a human, or in some cases even not a human, starting this whole interaction with a request. But now we have a very complicated set of interlocking AI systems and large language models performing some autonomous task. And so what is this agentic AI? Oh, no, these are not my latest slides. Oh, well. OK. I guess not. Well, I'll just talk over this slide for a second. So what is an agent? An agent isn't just a large language model. It's a large language model that's surrounded by what I'm going to call infrastructure. And by infrastructure, I mean the software that allows the large language model to actually do things. So this includes things like marshaling data between an API, potentially type checking, rule-based enforcement of policies. Another word for all of this stuff that we surround our large language model with that makes it into an agent is computer science. Now, there's a lot of reasons why this is a really good idea. LLMs are incredibly powerful. They're the only method we know of to solve all sorts of problems that were previously unsolved. Right? For many decades, we've been trying to crack all kinds of challenging problems, and large language models come along and they can do these things. But at the same time, they're probabilistic and they're non-deterministic. It's precisely the opposite of software, for the most part. Software tends to be deterministic, for the most part not probabilistic. We can understand it, we can inspect its state, we can make assertions about it. And so an agent is really the combination of these two things, where you take the intelligence from this probabilistic machine-learned large language model, but you surround it with the determinism and the power of computer science, data structures and algorithms, and the many decades that we've spent learning how to be good at building software and make things reliable. Now, an agentic system, then, is this complicated interaction of all of these things. A typical agent, right, you have some way of managing the prompts that go into the large language model that you feed the large language model with. You typically have some infrastructure that allows the large language model to access tools, potentially check permissions. All of these things are running on an increasingly complicated hardware substrate now. So some of the software that this agent is going to invoke runs on accelerated computing infrastructure, like GPUs. Some of it runs on CPUs. You have very complicated storage hierarchies now. You have agents and sub-agents. You have scoped data that needs to be passed between these different systems. You have communication patterns that are becoming increasingly complicated. Sandboxes, secure enclaves, all sorts of complicated things. Now, the platform is heterogeneous both at the hardware and software level. And not to mention the collection of models. So you have large models. You may have small models. You may have models that you have fine-tuned and specialized in some area. You may have a general-purpose proprietary model that's hosted externally on an API. And all of this works together to solve some complicated autonomous task. We call this platform, NVIDIA's version of this platform, we call the Nvidia Agent Toolkit. And it's a collection of things like deployment. So for deployment, everything from Kubernetes to, again, hosted infrastructure, computer use agents. It also has accelerated tools, so what we call CUDA-X, which is a collection of tools, for example, for computational fluid dynamics or solving differential equations or computing, secondary analysis of DNA sequences from DNA sequencing instruments. All of these, again, more computer science kind of tasks that we have accelerated solutions for, APIs and tools for, which are now made agentic. So your agent has access to this wide variety of accelerated tools. And then a collection of open weight models. So the Nemotron models, which is our family of general purpose models. We have more domain-specific models in robotics, physical AI, BioNemo, which are predictive models for biology. And again, all of this is running on this very complicated infrastructure, which includes the ability to deploy and run all these different models, the ability to have sandbox environments that surround the system to ensure that your AI isn't doing something you didn't want it to do, and ideally running all this in an efficient way. We also have built into this infrastructure, typically, you also want to be able to capture the knowledge that's flowing in and out of the system, and then you can use that to post-train a model to be specialized in a task that you care about. And so I would include in the infrastructure itself also this ability to, in an offline way, improve the AI, for example, with post-training using reinforcement learning. This is often performed to take a small model and specialize it to make it very good at some tasks, just as good as a much larger model would be at a more general purpose. I also want to talk a little bit about the actual interface between this agentic system and the large language model, and this is what people refer to as the agent harness. So the harness really matters. The large language model encapsulates a lot of intelligence, but this is, for example, recent work from my group to develop a harness we call the NEMO object-oriented agents. And the idea here is very simple, and if you check out the link on this QR code, you can find this project on GitHub. The idea here is that an agent is simply a Python object. And what do I mean by that? Well, you write your agent in Python, and there's this special syntax with this ellipsis notation, which basically says to the LLM, hey, fill this block in with code. And so the LLM is able to, or sorry, the agent is able to actually modify itself. So you can execute, it can call methods that it has written, and it can modify its own methods. It can decide this is some information I need to store, and actually include it as state in the Python object. It can take some plan or some way that it solved a problem and encode it in Python as a method and call it in the future. Another really important idea is rather than passing around all this information as strings compacted into some very large context, you can just pass things by reference because they're all Python objects. In this case, and if you check out the tech report, you can see more results. You can get significant lift over just a large language model or even over other agent harnesses just from a lot of these ideas integrated into your agent harness. And so we have results where we can get, for example, the same score but using half the tokens, or this CyberGym score, which is among the strongest CyberGym scores. And the lift from the harness in this case is significant. So this Nvidia Agent Toolkit encompasses, as I said, all of these things. We have models, we have deployment technology like NIMS and Dynamo. We have tools built into the infrastructure for capturing traces like NEMO Relay, routing algorithms like SwitchYard. We have what we call blueprints, which are open source reference implementations that show how to pull all these pieces together to solve specific tasks, whether it's building an OpenClaw or AIQ, which is a like a research assistant agent. And then we have runtime technology like OpenShell, which is essentially a firewall that allows you to control access between your agent and the outside world. And a lot of this is being deployed and adopted by many of our partners. And with that, I'll wrap up, and I look forward to the panel. Thank you very much.